Hello everyone. In this video we're going to talk about wide column stores. We already mentioned this type of database in our previous lectures when we're talking about NoSQL. So wide column stores or also they are known as column family stores. What they do is they create a big table with rows where each row has an ID, and there are some columns, but now they are not independent, not all of them. In the case of the wide column stores, we have families of columns. That means that a column that belong to the same family, they have to stay together. Now, what are the popular implementation of wide column stores? So for sure, Google's big table, that was the first one. So they came up with the idea of working with wide column stores. A similar software, so, it's HBase, which is the open source version. In general, they are the same thing. They do the same. They follow the same principles of wide column stores. And in this video, we're gonna go over on how it works, how they work, and also to understand the way in which data is stored when we have big tables. Okay, so when we're working with SQL, typically we want to normalize data. Remember that there are different principles of on how to normalize data. So the idea is like to minimize redundancies, is to have multiple tables. That's when you're normalizing data. However, in the context of big data, that's expensive. I mean, if you have multiple tables and then you perform a lot of joins, that costs a lot of time, that consumes a lot of resources. So in big data, we want to minimize the joins operation, that again in the SQL they were normal and they were desired, but here again when we have the large scale data, they are not desired. So the idea of these big tables or wide column stores is to move from normalized tables, and the idea is to denormalize those tables to create one big table. Of course, there are some problems because now we have like a replication of data, so you have like the same value multiple times in your table. That's possible when we do this, when we combine the multiple tables. However, from the point of view of resource consumption, it's more efficient. Okay, so what we want to get at the end is to have one big table, and again there is only one ID. This is our key, right? This key is unique. It's not like in SQL that where it's possible to have multiple IDs, multiple keys. In the case of wide column stores, we will have only one, and that key it's gonna reference a single row. Now, in the case of the columns, we'll have column families. They might have only one column, two or multiple columns. We need to define this at the beginning. When you're creating your table, it's important to create the schema with which families you're going to have, what are the columns that belong to each family. But of course, it is possible to add new columns once the table has been created. That's possible. At the same time, you can remove some columns if it's required. Now, what is relevant about the column families is that we're going to try to keep them together. So when you're splitting data, remember that at some point when you have big data, you need to distribute your data among different nodes. So when you're going to do that, the idea is to keep together observations that belong to the same column family, because that's data that is related to each other. Okay, now if we go to HBase, which is the open source implementation of wide column stores, one of them is there are like 4 key commands. So we have get, put, scan and delete. So what is the get? The get operation is used when you want to retrieve a specific row, one row. So here we have some examples. So this is the general syntax. So we're going to get from this table, the table name, what is the key of the row that we want to visualize. So that will give you all the columns for that specific row. So here's a particular example. So from the table students, we want to get, and this is the idea, all the information or all the columns for a student 1. That's the row key, right? Or if you want, if you don't want to get like all the columns, it is possible to get only some of the columns. For example, so from the same table, students get the row ID student 1, that specific student, but only you want to see from the info you want to see the name, right? So that will give you only that specific column. It's very intuitive. So this is what you get from get. You will get a single row, Put, this command is used in HBase to update or insert new data in the table. So the general syntax is, okay, put the table, the name of the table, which is the row key that you wanna either insert or update, and then the column family and the value. Column family, the specific column name and the value. So here we have some examples. We have like 4 puts using the same table. The first 2 are for student 1. So for student 1, in the first example, we have, okay, we want to change from the family column info, we access to the column name, and we want to add it or change it to Alice. Same thing now, but for another different column, which is age. And here we are again, or inserting, or we are updating information to 22. So they are straightforward. Both of them, get, put. We have scan. The difference between scan and get is like in scan you can retrieve multiple rows of data. Remember that in get you get only one, but a scan will give you multiple rows. So here we can set some conditions or specify like a range for a specific variable, so you will get multiple rows. Here is an example. The last one, scan students, the table of students, and limit 2. That will give us the first 2 rows. So not just one row, it will give you 2 rows, right? Because you're limited to the first 2 rows. You use also scan, not just to retrieve multiple multiple rows. It also works when you're performing multiple operations. Okay, like, okay, scan rows that follow or satisfy some conditions and then perform some operation like count, like the average or something. So you can use scan in those scenarios where you want to perform like multiple operations using multiple rows. Delete, I guess that one is yeah, it says everything. So the idea is to remove data. So you can specify a column or a common family or an entire row. So here, let's delete a specific column, age, for row student 2. So delete from table students, the ID students 2, and delete the information about the age. You can remove also an entire row. For example, here we delete all from table students, and you provide then the row key, which is student 1. So that's gonna remove the entire row. All right. So now let's understand, and I believe that this is the most important part about the white column stores in our course, is to understand how the information is stored. I mean, how once we have defined the table, the column families, and we have all the information, so how the information is managed and stored in the different nodes in a network. So let's understand the physical layer. So for that purpose, let's talk about regions. So once we have our big table, you can define regions. So to define region, you need to mention, okay, what is the minimum row ID that's going to be included, and the maximum row ID. So the idea here, this is a region. That means that this is going together. So we're going to try to keep that region together, right? So these rows and all the columns in those three in these three rows are going to be included. Please notice that the minimum value here is included, but the maximum value is excluded. This row ID is excluded. Why? Because this is the minimum of the next region. So that's why the max is not included. Because again, it's the minimum for the next region. So the idea, this is like the representation. It's very similar to when we're talking about HDFS. So here we have an H master, right? And then we split data in the region servers. The idea is that information from the same region is gonna be together. Let me show you a different representation. It's like this. So we have, this is like region 1. And the idea is that the information of this region is gonna be stored in the same place, right? So these are like our machines. So we're keeping together all the information for that specific region. And if a region is too big, it can be separated in multiple blocks. Okay, now there is also a smaller unit than the region in the physical storage. So remember what I mentioned at the beginning, that at the end you want to keep information from the same family column together. So this unit that we have here is stores. You notice the stores. So the first store here, this one, refers to the first region and also this family, this column family, right? So this is a unit to be stored here. The second one here belongs to the same region, but it's a different column family. So you don't want to split this. So that's what we call a store unit. So a store is equals to column family. And then we go from stores to H files. So again, this is the physical representation on how the data is actually stored in our network. So let me show you what is an H file. An H file is just a key value pairs. It's just a list of key value pairs. So here you have the key, and here you have the values. This is why we have covered this topic several times. We have talked about key value pairs because they are relevant in the representation of NoSQL data, and this is really important in big data because we need these structures in order to split our data in multiple nodes. So let me show you a little bit more about the H file. So this is our storage unit here, right? Which it looks like a logical table, like a table. But the way in which it's translated to a key value pair is like this, okay? So we have the row ID, right, which is the key, and we have the column name. Here we have 1, 2, but this can be named, right? You cannot say any name. Remember in our previous example, this can be age, right, or the name of the student. It can be anything. Now, the way it works is like it combines the row ID with the column name. So this is A1, A2. So this value here, for example, is stored in A1. This one is stored in A2. So this is what we're doing here. So we get A1, A2. So the red one, this is A1. Then we have A2, B1, B2, C1, C2. These are the keys. And of course, to the right, we will have the values that are stored here in the cells, right? It can be anything. It can be text. It can be an integer value. Yeah, it can be any piece of information that we have stored in that specific cell. So this is how we get the list of key value pairs that I mentioned in the previous slide in our H file. And this can be translated to the key value. We can translate this to okay, we have the key, the value. We can have the key length, the value length, and this is how this is stored physically in the different nodes in a network when we have big data. So we kind of like we began with a structure from a table. At the beginning we had a big table. Then we split that big table in regions, right? Using some row IDs. Remember the minimum and the maximum row ID. And then stores, and remember in those stores, those are pieces of the region where the only condition is like we're keeping together observations, but with ensuring that the column families, those values are together, right? And then we move from store to H file. So that's the list of key value pairs. So this is how we store data. Thanks to this, it is possible to split it across different machines. All right. So what are the key points here when we're working with this type of white column stores? First, we have high scalability, especially horizontal scalability. We can keep increasing the table, like adding more columns. It's a flexible model because you can remove, add columns. It's efficient for certain workloads, and it provides high availability and fault tolerance. So with this, we have concluded discussing 4 different NoSQL structures that are critical when we are working in big data. Okay, I'm going to stop the video for today, and I'll see you in our next lecture.